screen recording. Alright, so this is my agenda for Algebra 1. Please pause the video for the students to copy this down for a couple of minutes. Now that they're done copying the agenda, pause the video again to give them a couple of minutes to copy this down. Probably like 5 minutes. Now, let's go continue with section 1.4, equations and inequalities. So everybody, just listen up very carefully, and I'm going to break this down to you as simple as possible. So look at the vocabulary, equation. An equation is formed when an equal sign is placed between two expressions, creating a left and right side of the equation. And if you don't know what an equal sign is, this is an equal sign, not testing your knowledge. Okay? So let's go look at examples of an equation. So like I said, an equation should contain an equal sign because the root word eque, which is, equal. Okay? 4 minus b equals 3. That's a form of an equation because there's the equal sign. And 3x plus 1 equals 7. So you have the left and right side of the equation in between the equal sign. Then lastly, we have a plus 3 equals 3 plus a, and that is an equation because it has that equal sign to connect the left and right side. Two expressions. Okay? Now, look at the asterisks that I put down. If equation is true when a variable is replaced with a number, then it is a solution of an equation. And we'll go over this at the next page of finding the solution for an equation. Okay? Easy so far? Now let's go to the next page. So go ahead, pause the video, and have the students copy this for a couple of minutes. Okay, now that they have copied this down, assumingly, so check whether the numbers 2 and 3 are solutions of the equation 3x plus 1 equals 7. So all that means is we're going to replace x with 2 and 3 to check if it checks off 3x plus 1 would equal 7. Okay, so let's go through the number 2 first. So if we replace x with 2, okay, so that means substituting the x with 2, 3 parentheses 2, like I said, have that habit of changing the variable with the parentheses when you replace it with a number. 3 times 2 plus 1, would it equal to 7? So let's go break it down. 3 times 2 is 6, plus 1, that gives us 7. So yes, it is a solution to the variable x, when you replace it with 2, is a solution for 3x plus 1 equals 7. So we conclude by saying yes, when x equals 2, it is a solution. It is a solution to 3x plus 1 equals 7. Okay? If there's any questions, hold that off till I come back. Okay, so when we replace x with 3, let's verify if that equals to 7 when we replace it in the variable. So let's replace x with 3. 3 times 3 plus 1 equals 7. Okay, now I hope you guys are following along and just saying it as I go. 3 times 3 gives us 9, plus 1 gives us 10. But does that equal to 7? No, it does not. Okay, so when you conclude, you're going to say no. When x equals 3, it is not a solution for 3x plus 1 equals 7. Okay, so all you're doing is basically saying you're verifying if those numbers work when you replace x and if it equals the number, whether if it's on the right or left. Okay, you're just saying yes or no if it is a solution. That is basically it. saying yes or no, but you have to verify by solving. Got it? Okay, so let's try another example. Okay, then you're gonna try this on your own on the next page. Okay, so check whether the numbers 2, 3, and 4 are solutions of the equation 4x minus 2 equals 10. Now, so you're gonna replace x with what numbers? 2, 3, and 4. Okay, so when we replace x with 2, 4 times 2 minus 2 equals 10. Now, follow along. 4 times 2 equals 8 minus 2, which is 6. But does that equal to 10? No, it does not. So no x, when x equals 2, it is not a solution. Or you can just say x equals 2 is not a solution. Okay? You don't have to write it how I'm saying it, but just say no, x equals 2 is not a solution. That is basically it, in your own words. Now, let's go look at 3. Verify 3. So when we replace x with 3, okay, 4 times 3 minus 2 equals 10. So let's go over it. 4 times 3 gives you 12 minus 2. It is 10. So yes, when x equals 3, it is a solution. Okay, good so far? Alright, so let's go use 4, replace 4. Now, 4 times 4 minus 2, and does that equal it to 10? Okay, let's solve it. 4 times 4 gives us 16. 16 minus 2 gives us what? 14. Does that equal to 10? 14 equal to 10? No, it does not, because 14 is not obviously equal to 10. So you're going to write down no when x equals to 4, it is not a solution. Good so far? This is really easy. All you're doing is plugging in the numbers for the variable and just saying yes or no if it is a solution to the given equation. Okay? If there are any questions, you can ask Miss Dim if she needs to clarify any of your questions, okay? And thank you, Miss Dim, for helping me out while I am gone. Okay, now let's move on. Okay, give the students a couple of minutes to copy this down, so you can pause this video right now. Now, go ahead and try this on your own, and we'll give you guys about 7 minutes to complete this. Okay? Then once the 7 minutes are up, give Miss Dim your answer and see if you got the correct answer. And we're gonna go over this. Okay, so let's go over the first problem. Alright, so if you see the semicolon, that means that it's just separating the variable, the number of the variable that you're going to be replacing. So for example, 5 plus x squared equals 17. So you're going to replace x with 3. Okay, so whatever's after the semicolon, that's what you're replacing the variable with. So that means 5, then put the parentheses, 5 to the second power, or 5 squared, equals 17. Okay, so you're going to verify. So solve the left side to see if it equals the right side. Okay, so what do you do first? Order of operations, right? We went through that. So you're going to solve the exponent first. So you're going to rewrite that as 5 times 5. Okay, so now let's go rewrite it here. So 5 plus 5 times 5 and equals 17. So now what's 5 times 5? Should be 25. Okay, now let's go rewrite this whole left side again. So it's going to be 5 plus 25 equals 17. So when you add 5 plus 25, what does that give you? Gives you 30. But does that equal to 17? No, it does not. So that means 3 is not a solution. 3 is not a solution. Just say 3 is not a solution for this particular problem. 5 plus x to this second power equals 17, okay, for this equation. Now, let's move on to the second one. So 2y cubed, or to the third power, plus 3 equals 5. When you replace y with 1. This should be very simple. So let's replace y with 1. 2 times 1 raised to the third power plus 3, and does that all equal to 5? Okay, again, let's go solve the left side so we can make it look like the right side. Alright, so we start off in PEMDAS with exponents. So you're going to rewrite this as 1 times 1 times 1. So let's rewrite it. So 2 times 1 times 1 times 1 plus 3. Now, what does this equal to? 1 times 1 is 1, and 1 times 1 again is 1. Now, let's go rewrite it again. Okay, this is equal to 5. So that's going to be 2 times 1 plus 3 equals 5. Now, 2 times 1 equals 2, then plus 3. Does that equal to 5? Yes, it does. So that means 1 is a solution. Okay, so all you're doing is verifying if the number after the semicolon is a solution to the equation on the left right here. Got it? Okay, so I want you to do the last one on your own, and we'll move on to the next page. Okay? Sorry, this is the first time I am doing a video to teach you guys. So if you guys are laughing right now, or, you know, just wondering why I'm stuttering a little bit, it's because it's a different feeling. Okay, so checking solutions of inequalities. I'll give you guys a couple minutes to copy this down, so please pause the video. Alright, so you guys should have copied this down already. Now, checking for solutions of inequalities. Okay, inequalities comes in the form of the less than sign. Alright, which is this. Then there's the less than or equal to. There's the greater than, and the greater than or equal to. Okay, and you can see how it's said just by reading the description under meaning. Okay, less than or equal to, greater than or equal to. Got it? Okay, now in the asterisk in the red, a solution of an inequality is a number that produces a true statement for the variable of the inequality. So meaning when you solve it, just like what we've been doing before this page, if the number is true, when you replace the variable, if it's true for the statement, then it is a solution. So let's go over some examples of what I'm talking about. So decide whether 4 is a solution of the inequality. Now, for letter A, when you replace x with 4, let's replace x with 4. So 2 times 4 minus 1, is it equal, or sorry, is it less than 8? So let's solve it. So 2 times 4, follow order of operations, is 8 minus 1 gives us 7. Okay? So is 7 less than 8? Yes, it is. So that means 4 is a solution to this for letter A. And you can just say 4 is a solution because it refers to A already. Okay? So, if you guys are still confused in how to read inequalities, even if we mentioned the meaning already. So the mouth is always eating the bigger number. Okay, so in this case right here, the mouth is eating 8 because it is the bigger number. So let's go to B to verify that. So when we replace 4, or when we replace x with 4, okay, then plus 4, is it greater than 9? So 4 plus 4 is 8, and it states that 8 is greater than 9. Is that true? No, it is not. 8 is not greater than 9. So no, 4 is not a solution. It's supposed to be in blue. 4 is not a solution for letter B. And you can just state that. Okay, so all you're doing is just replacing the variable with the number it's assigned and just verifying and saying yes or no if 4 or whatever number it says is the right statement for this problem. Okay, so lastly, C. Let's replace x with 4. Okay, so 4 minus 3 greater than or equal to 1. Okay, so when you solve it, 4 minus 3 gives you 1. And just rewrite it, greater than or equal to 1. So is that true? 1 is greater than or equal to 1. So some of you might say, no, it is not, because greater than. But that's why I said greater than or equal to, so that or meaning it can equal to it with this symbol. So 1 is equal to 1, yeah? So that means yes, 1 greater than or equal to 1 is a solution, or it is a true statement. So that means 4 is a solution to C. Does that make sense? Okay, so we're going to have more practice on this, so let's move on to the next page. Now go ahead and pause the video and give these guys a couple of minutes to copy this down, and an extra couple of minutes for them to do this on their own, and we'll go over it together. Okay, so you should have been done copying this down and going over it to yourselves. Now, so like I said, whatever's after the semicolon, that number replaces the variable, or in other words, the letter. So try these on your own. Check whether the given number is a solution of the inequality. Now, 5 plus, what are we replacing s with? S replaces with 4. And is it greater than 8? So 5 plus 4 gives us 9. And is that greater than 8? 9 is greater than 8. Yes, it is. So that means 4 is a solution for letter A. Does that make sense? Okay. Now, let's go to letter B. So we're replacing P with 2. So let's go. 4 times 2 minus 1 is greater than or equal to 8. So let's solve. So what do you do first? You multiply first. Order of operations. 4 times 2 gives us 8. Minus 1 is greater than or equal to 8. 8 minus 1 is 7. So is 7 greater than or equal to 8? No, it is neither greater than or equal to, because 7 is smaller than 8. So that means 2 is not a solution for letter B. Is it making it so much clearer for you guys? Okay, all you're doing is just verifying if these are true by plugging in these numbers, replacing the variable. Okay, so let's go to C. We're replacing x with 9. Okay, so 11 times 9 is less than or equal to 9 minus 7. Okay, so let's solve. 11 times 9 will give us 99. Okay, then let's solve the right side. Is less than or equal to 9 minus 7, which gives us 9 minus 7 is 2. So is 99 less than or equal to 2? No, definitely not, because 99 is greater than 2. So this statement is false. So that means 9 is not a solution for this problem, for letter C. Okay? So go ahead and hold any questions for me next class, or if Ms. Dim can provide you your answers for your question, then thank you so much, Ms. Dim. Okay, so that is it for chapter 1.4. Okay? So we're going to move on to 1.5. So if they don't have enough time, if the bell's about to ring, then they can stop here. I will continue this when I get back with them. And so if not, if they still have time, then we'll continue with this. Now go ahead and pause the video and give them a couple minutes to copy this down. Okay, so they should be finished copying this down. Now, welcome to section 1.5, a problem-solving plan using models. Now, don't let the title scare you. Okay, this is probably easier than the past lessons we've been going over. Okay, so look at this verbal phrase chart. Now, you can find this in the textbook. Okay, so under verbal phrase, if you see these terms, sum, more than, plus, increase, that's indicating that you're going to be doing addition when you're expressing it or changing these verb phrases into expression form. Okay, meaning just number form, putting it into numbers. Okay, so if you go under subtraction, under operation, so if you see verbal phrases such as less than, difference, minus, decrease, then in your expression, when you change it to number form, you're going to see subtraction signs as your operation. Check. Okay, multiplication. If you see the words times, product, multiplied, then you know that when you change it to number form, your verb phrases, it's going to become multiplication. Now, when you go to division, the verb phrases you need to catch is just divided and quotient. Okay, and that's going to symbolize that when you transform these words into word form or number form, it's going to be division. Okay, so it's very crucial to use this chart if you're confused how to convert word form to number form. Okay, so let's go over some examples. Alright, and if this is going by pretty quick, you can pause the video and ask questions, but hold questions till after all the examples are done. Now, translate the phrase to algebraic expression. In other words, translate it to number form. Okay, so 3 more than the quantity 5 times a number n. Now we're going to translate this to number form. So how would you start this off? So what verb phrase do you see in this problem? It says more than, so that means you're going to add. That's what the operation is going to be. Now, 3 more than a number. So you got to read it really careful and make sense of it if you want to change it to word form. So 3 more than a number, that means it's going to be what? 3 more than the quantity number 5 times a number n. So that's going to be 5 times a number n, meaning they multiply, more than 3. 3 more than that quantity 5 times the number n. This is how you rewrite it in number form. Okay? Now, go ahead and go to the next question, or to the next problem. Now, 2 less than the sum of 6 and a number. Okay? So this is kind of tricky. So 2 less than a number, less than is what under verb phrase? Subtraction. Okay? Less than the sum of 6 and a number. So you're focusing on two operations now, less than and the sum. So less than, when it means less than, you're going to subtract, okay? So go ahead and follow that. Less than 2. Okay? When it ever says less than, then you're subtracting that number from whatever's given next. So whatever's given next is the sum of 6 and the number. So that's when parentheses is crucial. Okay? So when you get to the parentheses, the sum of 6, and sum meaning addition, plus a number, okay, and a number. And that number should be m. Sorry, I forgot to include m. 6 plus m. Okay? So this is how you rewrite it in number form. Okay, let's go to C. A number x decreased by the sum of 10 and the square of a number y. Now, this is a bit tricky because there's so much operations going on here. So just break it down by operation. So a number x decreased. So decrease is a verbal phrase. Okay, underline that. By the sum of 10. So sum, that's another operation. And the square of a number, that is another operation. Or technically not an operation, but an expression to solve. Okay? Now, how do you rewrite this? Now, a number x, so let's go write that. X decreased. So notice it's a bit different from b, because less than meaning you're taking away from whatever you're doing, which is 6 plus m. So x decreased by the sum of 10 and the square root and the square of a number y. Okay, minus 10 plus the square of the number y. Square is the power. Okay, and this is how you convert it to word form. Okay, so if this wasn't as simple, I know this was a bit difficult to understand. Let's go through some more exercises because practice makes perfect. Okay? So, go ahead and copy this down. We're pretty much done with 1.5 and 1.4. Like I said, we'll have more exercises in this classwork going through these problems under 1.5. Okay? So if there's not enough time, you're going to do this classwork when you see me next class. Okay? So that is it for Algebra 1 for sections 1.4 and 1.5. Thank you, Ms. Dim.